Everyone, in this session, I'll be covering what are the different operators available in Python. So, as you can see on the screen, I've listed down different operators that we deal with. So the basic one, the most fundamental one is the arithmetic operator. This is very easy to understand. So, for example, if you have to add two values like 2 plus 2, so we use this particular character to do the summation, this character to do the subtraction. Asterisk is used for multiplication, and this backslash is used to divide two values. One probably a new thing would be percentage. So percentage is basically used to calculate the remainder of a certain expression. So for example, if you are going to calculate 4 divided by 2, okay, I'll just open it here. I'll show you. So if I want to calculate, say, 4 percentage to, it will show you 0, because when we divide 4 by 2, the remainder turns out to be 0. If we do 5 percentage to, it would be 1, because the remainder is 1 in our case. The double asterisk is being used to calculate the power. So say for example, I do 4 square, it turns out to be 16, because 4 to the power 2 is 16. Similarly, if we do 3 to the power 3, it is 27. So this is, we calculate the uh, exponents. The double backslash is basically used to calculate the floor division. So for example, if we divide 5 divided by 2, the value turns out to be 2.5. Whereas if we had 2 backslash in our expression, it will fetch us the floor value. So in our case, it is 2. Okay. So for example, I do 9 divided by 4. The value is 2.25. Now if I do 9 double slash 4, it will result us into. So basically, we are just calculating the floor value through this. So now coming to the assignment operator. So the first one is pretty simple. If you have to assign any variable, any value, we use this equal to sign. So say for example, I do x is equal to 4. So basically, as you can see, x value is 4. So this is basically assigning values. Plus equal to is nothing but assigning, that is equal to, and assigning what? The summation of something. Okay. So for example, if I say, um, we have x, right? X is equal to 4. Now if we want to add 2 to the variable x, whatever it is there, so what we'll do is x is equal to x plus 2. Okay, now we will see x is equal to c. X is equal to, as is x is equal to 6. Had there been a case where I had to handle, instead of writing the whole this big expression, we can handle it using the expression that operator that I just showed. We can write something like x plus equal to 2. This will fetch us the same result. Okay, so it's nothing but assigning the summation of something into a certain variable. Okay, on the similar lines, there is minus equal to, asterisk equal to, slash equal to. Okay, next is the comparison operator. So as the name suggests, this basically compares two values or two expressions to. Okay, so for example, in our case, if I will say 5 into 2 is equal to 6 into 3. So this turns out to be false, because 5 into 2 is 10 and 6 into 3 is 18. So 10 cannot be equal to 18. That is why we are seeing this expression as false. Okay. So as you can see, for comparison operators, the resultant would always be a boolean, that is true or false. Okay. For example, if I, instead of putting this double equal to, had we put this not equal to, is what we call this, this would ideally turn out to be true, right? Because 10 is definitely not equal to 18. So this is how we calculate not equal to. Okay. Now okay, uh, then there is this greater than, less than. So this is very easy to understand. So 5 into 2 can never be greater than 18. Okay, so if we check this, this would return us false. The other way around, if we check, that is 5 into 2 is less than 6 into 3, it turns out to be true. So here we have achieved uh, true because 10 is definitely less than 18. So this is how we use the greater than less than operators. Then there is greater than equal to and less than equal to. So basically, it basically compares two different expression and checks the resultant value is equal to or greater than the certain value. So for example, if I'll do 5 into 2 greater than equal to 6 into 3, this will return false because 10 can never be greater than equal to 18. Okay, whereas if I do the other way around, less than equal to 6 into 3, sorry, this turns out to be true. Reason being, definitely 10 is 10 is not equal to 18, but it is less than 18. Okay, so this basically it compares less than or equal to. Okay, it is something like less than or equal to. So this is how we basically use this operator as on similar lines. The other one next is logical operators. So basically this calculates two different expressions, and the resultant of those, which is basically a boolean, is again being subjected to all these operators. I'll show you exactly what I'm trying to say. So say for example I have two expressions. Okay, one is, say the first expression is 5 into 2 less than equal to 6 into to 3. Okay, then there is different expression wherein 4 into 2 is equal to 2 into 4. Okay, this is the second expression that I have. Okay, so basically if we'll check a turns out to be true because definitely 10 is less than 18, and b turns out to be true as well. Okay, now if I say a and b, so true and true would always result us as true. Okay, and true or true will again also result it as true. Okay, had we have a situation wherein we have a third expression, where say for example 2 into 3 is greater than 5 into 5, this definitely is not possible because 6 is can never be greater than 25, right? So c is false. Okay, now if I subject this to the and operator, a and c, what it will return false. Reason, because it basically compares true and false. So true and false would basically always return false. Okay, had it been or, things would be completely opposite. It would return true because true or false would always return true. So if at all you have this knowledge of truth tables in your in any of your subjects, you will understand that 1 and 0 is always 0, 1 or 0 is always 1. So basically it's on the same logic. Okay, so this is what your logical operators are. Not is a special one where not of true is always false. So basically whatever the expression, the comparative expression throws you the result, it is going to the not operator against it will always show you the opposite result. Okay, so as you can see, c is false, but not of c will be true. Then this is identity operators. This is basically somewhat equal to only. So if we'll say r is r, just a second, r, because it is expecting r to be a variable which is not defined, whereas I should put it as character. Yes. So basically, as you can see, it is just showing throwing you a warning, because this is rarely used. Whenever we equate, we always use the double equal to as a normal solution, but here is also a way of handling this, but it's not generally preferred. Okay. And r not is, just should ideally r is not, yeah, is not r. This is one correction that I have to do. It should be is. Sorry. Okay. Now the next one is a membership operator, that is in and not in. So basically here what we do is that out of a sequence, we basically check if a value is in that sequence or not. So for example, say I have a list. I have to check if one is in list one, two, three, four, five. Sorry. Should- So basically it checks that in this particular sequence, if one is a part of the sequence or not. Okay. So yes, definitely one is part of the sequence. So our result is true. Now if I say one not in one, two, three, four, five, so this will throw us false because one does exist in the list. Whereas this expression is basically trying to check that one is not a part of this list. So basically, since it is a part of this list, it should always result you false in case of not. Say for example, now I say 6 not in 1, 2, 3. This would throw you true because definitely 6 is not part of the sequence, right? So this is pretty much about different operators that we have in Python. We do also have a bitwise operator, but then that is something not being used that often. So just play with these different operators, and you'll get the understanding in a much better way. And okay, so we'll meet in our next session.